Today's video can be found on your Unit 1A packet, and we're on pages 15, 16, and 17. So as you can see, the first page here is the problem of the day. This is where I'd like you to do some thoughts on your own on these couple questions. So working on your own, pause the video now and answer questions 1, 2, 3, and 4 to the best of your ability. Make sure, number 1, hint, 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 you know the difference between an algebraic expression and an algebraic equation. So, hint on number 1. So, pause the video now, give it your best shot, page 15. So, on to page 16, the lesson for today. Solving real-world problems involving linear equations with one variable. And you can see that I wrote in here, and hopefully you're writing it in, that you can find this either in the 7th grade text, Chapter 4, Section 3, or the 8th grade text, Chapter 3, Section 1. On page 99 is this exact picture here with this gentleman. So a belt costs $30 less than a pair of jeans. The ratio of the cost of the jeans to the cost of the shirt is 2 to 1. If the total cost of the 3 items is $75, find the cost of the jeans. Well, you could represent that with a bar model, 2 to 1. So the cost of jeans to shirt, jeans comes first, so that goes along with the 2. So you can see jeans down here as 2 x's, and the shirt only has 1 x, and all together our picture, the 3 items, oh, and the belt, which we don't know, oh, $30 less than a pair of jeans. So if the jeans is 2x, then 2x minus 30 is the cost of the belt. So the 3 items here altogether cost $75. So here's the picture way of solving it. But you could also use an algebraic expression to do that, because altogether they cost $75. I could add my x for my shirt, my 2 x's for my jeans, and my 2x minus 30, the little orange part here, for my belt, since it's $30 less than the cost of the jeans. So this picture is kind of like our let statements. Let x equal a shirt, let 2x equal jeans, let 2x minus 30 equal a belt. So putting that into an equation, x plus 2x plus 2x plus 30, all together they equal $75. Well, we've got like terms here, so we're going to put our like terms together, and we have 5x's minus 30 equals 75, and then balancing our equation, we always add or subtract before we multiply or divide. We're using our inverse operations, and we get 5x is 105, and when we divide by 5 on both sides, canceling, we get x is 21, yes. But we have to answer what is 2x. 2x. So 2 times 21 would be 42. And we have to answer what's 2x minus 30. So 42 minus 30 would give us 12. Make sure that you answer the value for each of the items in your algebra. But then when you go to Sable the problem, sentence answer box label, answer the question that's being asked. We don't want to say that the shirt costs $21, the jeans cost $42, and the belt costs $12. That's not what it asks. It says, find the cost of the jeans. So we're going to say the jeans cost. Only answer the question that's being asked. The jeans cost, $sign, that's my label, $42. And you can put the 0, 0 or not. Sentence answer box label. Nice full sentence answer. Does your answer make sense? Well, let's check it for reasonableness. If it's $42 for the jeans and $21 for the shirt and $12 for the belt, 2, 4, 5, 4, yeah, that seems reasonable. Or if we just said 20, 40, and 12, that's pretty close to 70, you know, reasonableness. Yes, the 3 items added to $75. And if you estimate them 20, 40, and 10, it's pretty close to 75. So is it reasonable? Yes. Next page. Oh, we already did this question number 1. Silly me. I already had it in the packet. We did it on homework 2. So, oops, go on to question number 2. A triangle has a perimeter of 105 meters. If the lengths of the sides are consecutive odd integers, oh, we've already seen this. Find the length of each side of the triangle. So I can either draw a picture or I can do let statements. Maybe I'll do both. The lengths of the sides are consecutive odd integers. So, you know, I'm just going to draw one. So this could be x, this would be x plus 2, odd numbers are 2 apart, and this would be the longest one, x plus 4. Or, again, I could write let statements, let x equal the first odd integer, let x plus 2 equal the second odd integer. So I could do it in a picture or let statements, don't have to do both, I'm just showing you both. Choose one. Third odd integer is that x plus 4. Okay, so, and they add to the perimeter of a scalene triangle here. The formula is a plus b plus c. All sides are different, so using 3 different letters. So following that, I'm going to have x plus 2 plus x plus 4, whoops, equals 105. So I get 3 x's plus 6, combining like terms there, is 105. Subtracting 6, balancing my equation, using inverse operations, I get 3x is 99. And then dividing by 3 on both sides, running out of room. I get x equals 33. Not done, not done, not done. Make sure you answer your other let statements. 33 plus 2 is 35, and 33 plus 4 is 37. And if I do a little check here, 33 plus 35 plus 37. Oh, I could do it right here. They're right in a column, so I'll do it right here. 7, 10, 15, carry the 1, 3, 6, 9, 10, oh, 105. Yep, there's my check. Didn't need to write it over here. And I have to answer the question. Find the length of each side of the triangle. Uh-oh, we run out of space here. The sides of the triangle. Full sentence answer. Are. What's my label? Meters. Okay. So 33 meters, comma, 35 meters, comma, and 37 meters. Sentence answer box labeled. Sable, sable, sable. Want to be literate with our mathematics. Question number 3. A store bought Y shirts at $12 each. It sold most of them for $16 each. And the last dozen were sold on sale for $14 each. It sold all of the shirts for $616. Find the number of shirts sold. Find the number of shirts sold. It sold most of them for $16. And it sold the last dozen for $14. Well, 12 times 14 would be 168. Where's the store-bought shirts at $12 each? Well, I don't need to know that. It sold them because I want to know what it sold them for. So that's a piece of information I really don't need. Sold most of them for $16. So I'm going to say let Y equal, or X, whatever letter, it doesn't matter. Let Y equal shirts at $16. So I sold a number of shirts at $16, so 16Y, this is a value problem, got to put that together. And 12 times 14 is 168. And by the way, all 7th graders in Common Core are supposed to know up to their 15s tables, so you should know 12 times 14. Up to your 15s tables, get memorizing them. We have $616 total. So there's my equation. Find the number of shirts sold. Subtracting 168 from both sides, I get 16Y's equals 448 when I subtract, and dividing by 16, Y would equal 28. So plus the last dozen were sold on sale for $14, so there were 28 sold at $16, plus the last dozen, so 28 plus 12, that means that there were a total of 40 shirts. We had to add that in. It sold all of the shirts for $616. So the $16 for the shirts that I found, plus this dozen that's right here, got to add those back in. So the store sold 40 shirts, would be my stable. The store sold 40 shirts. And we're going to do some more word problems just like this in class tomorrow.